Leetcode question 143, reorder list. You are given the head of singly linked list. The list can be represented as L0, L1, up until Ln-1 and Ln. So each Li represents a node. Reorder the list to be on the following form: L0 followed by Ln, and then L1, and then Ln-1, and then L2, and then Ln-2, so on and so forth. You may not modify the values in the list nodes, only nodes themselves may be changed. So in example 1, so we start with 1, 2, 3, 4, and then we insert, this is our Ln, insert after L0, and then this is our L1 followed by Ln-1. This example has even number of nodes. In the second example, we have odd number of nodes. So in this case, the L0, which is node 1, followed by the Ln, which is node 5, and then followed by L1, which is node 2, and then followed by Ln-1, which is node 4, and then followed by the L2. So this gives an example of the odd number of nodes. So the idea for solving it is in 3 steps. The first step is actually find the previous node of the second half of the linked list. So basically this is very similar to find the middle point. We are actually trying to use the two-pointer approach. Slow pointer moves one node at a time. So the initial position is just head, and the fast pointer 2 times speed of the slow pointer. The initial position is head on x. Why is head on x instead of head? That is because we want to find the previous node of the second half. So that's actually the node before the mid node. So so that's kind of the node before the second half. So in this case, when is the odd case? So when it's the odd case like this, the node we want to find is actually the exact middle nodes. So we want to find this node, and then this should be our second half. So we want to find the node before the second half. And then for the even case, we can actually exactly split them in half. In that case, the node we want to find is this node. So the first middle node, when there are 2 middle nodes. So that's kind of why this slow pointer should fall behind this fast pointer by 1 position initially. For the step 2, we want to actually split the original linked list in half based on what we find in step 1. So step 1, we find the previous node of the second half of the linked list. So this is actually equivalent to the end node of the first half. So this is aka the end node of the first half. And then based on what we find on step 1, in step 2 we just split the original linked list in half and reverse the second half. So it is still 2 pointers approach. We have previous pointer and current pointer. So before the reverse, pre-pointer's next node is just current pointer. After reverse, current pointer's next node becomes the previous node, the previous pointer. So that's kind of how we reverse the nodes. We're reversing it one by one. And then for step 3, we actually insert the nodes from the second half between nodes in first half. How it is this done? So basically we start at the head of both linked lists. So we start at the head of first half, that is original head. We also start at the head of the reverse second half. That is actually the last node of the original linked list. So in that case, we still use 2 pointers, basically to move along each half. So 1 pointer moves along the first half, 1 node at a time, and second pointer moves along the reverse the second half, 1 node at a time. The time complexity for this solution is O(n), and then space complexity is just O1. We are not creating any additional storage. So for step 1, let's code the step 1. So in this case, we have slow pointer and we have fast pointer. So slow pointer start at head and the fast pointer start at head on next. So the starting point for the initial position for the slow and the fast can be a little bit tricky, depends on which node we want this flow to stop at. So in that case, the best way to actually get some clarification is just to walk through some examples. Basically, let's say take this example 1 and example 2, the even case and the odd case. We're just trying to move the slow pointer and see, okay, when the fast pointer stops, what's the stopping location of this slow pointer? And then, well, this fast and fast down next. We just move slow pointer by 1 node. And we are moving fast pointer by 2 nodes. And then in the end, this slow pointer, it just corresponds to the end of the first half. It's also the node before the second half. And then for step 2, we want to split the original linked list in half and reverse the second half. So in that case, we use the 2 pointer, also use 2 pointer. One is called previous, and then the other one is called current. So for the initial position, so for the current pointer should always point to the first node of the second half, basically the first node of the linked list that we want to reverse. So in that case, that's denoted by slow down next. So this slow down next is just the first node in the second half before reverse. And then this previous pointer, so because we want to disconnect first half and the second half, so in that case, for the current node, the current node's previous node, so this current node is now the first node in the second half before reversing this second half. After reversing the second half, this current pointer will become the last node in the reversed second half. So in that case, remember, during the reverse, the operation is just current down next. It's just previous. That's kind of how we reverse. So in that case, for the first node, for this initial current pointer location, it will become the end node in the reverse linked list, and then its next node should just be none. So that's why we want to initialize this previous pointer to none. And then another thing is we need to disconnect. So we also need to disconnect node 1, linked list 1, the first half, from the second half. Remember, the end node of the first half is slow. So in that case, we set the its next node to none. So that's kind of how we disconnect it. And then we need to have a while loop. While current pointer is now none, we just set current pointer down next to previous. And then after that, we'll update the previous and current to be current, and then current down next. Okay, now we have a problem because current down next was already updated, but we still want this line, in this line, the current to be set to the original current down next. So in that case, we need a temporary variable to store current down next. And then we update this one to our temporary. So that's the part 2. The step 2, split the original linked list in half and reverse the second half. And then for the step 3, we are insert nodes. So first we need to find the head of first half and the head of the second half of the reversed second half. So the head of the first half, that is just the head, original head. The head of the reversed second half is just this previous pointer in the step 2. So that's, in that case, we initialize them with also 2 pointers, first and then second. So let's call it actually current 1 and the current 2. So basically that indicates the current node in the first half and the second half that we are considering. And then while current 1 and then current 2, we just move them. We just complete the insert and then after that we move it. So basically for the insert is current 1 down next, it's just current 2. And then after that current 2 down next should be the original current 1 down next. Now we have a loop because for this one we want it to be original value. Now the one updated in line 50. So we need a temporary variable. So temp1 is just current 1 down next. So in this case it's just temp1. And then after that we need to update the current 1 and the current 2 to be the temp1. This is the next node in the original first half. And then we also need to update to the original node in the second half. That should be current 2 down next. However, it's get override in line 52. So we need another temporary variable. So in that case, it's temp2. It's just current 2 down next. And then we update this one to temp2. And then after that, we just return the head of the linked list. That's our head. So let's run this solution. So this solution is accepted. So to recap the idea, the main idea is we divide it into 3 steps. First step, we find the previous node of the second half of the linked list. Basically, the overall idea is to split the linked list into 2 halves, and then reverse the second half, and then insert a node one by one. So you see step 1, we find the previous node of the second half, which is also the end node of the first half. So we use 2 pointers, so this is very similar to find the middle point. However, we should be a little bit careful with the starting point of the slow pointer and fast pointer. In this case, so for the odd number case, we want to find the exact middle node, and then this is our second half. For the even case, we want to find the first middle node. So that's kind of why the slow pointer start at head and the fast pointer start at head on next. And then we just move slow pointer at 1 node at a time, fast pointer 2 times of the speed of the slow pointer. And then in the end, this slow pointer is just the end node of the first half, also the node before the second half. And then for step 2, so based on what we have in step 1, we just split the original linked list in half and reverse the second half. So for the reverse, we also use previous and current 2 pointers. So basically, the key idea is this step. We just reverse direction. Previously, the node point from previous to current. However, after reverse, this direction should be reversed. And then we should be a little bit careful with the starting position of this previous and current, because what we are trying to do right now is also disconnect the first half from the second half to avoid forming a cycle. And then in step 3, now since we have the first half and second half for the second half we have it reversed. So basically we just start ahead of each and then just move 1 node at a time and then insert them alternatively.